Yeah, hello everyone. Welcome to today's afternoon session. So now we'll be starting the session on ANSYS Workbench. So in this ANSYS Workbench, we'll be performing the biomechanical analysis of a femur bone. So if you take a femur bone, it is the longest bone in the human body. So this is the longest bone in the human body, and this is the main bone, which is which will help you to run, walk, or do any push-ups or sit-ups. This is the main bone which will help us to make sure that you are freely moving, running, walking, push-ups, sit-ups, etc. So this is the longest bone in the human body, and if you are not taking care of it, it may have any breakage of the fracture of the femur bone in the human body. So in this analysis, we'll try to see what are the values up to which it can take the load on the femur bone. And there's another model. In the another model, when the femur bone got fractured, we have inserted the stainless steel material inside it, so that to have the stronger femur bone. That two models we have in this, that will analyze these two models. So in the research perspective, in the research perspective, we have to collaborate with any doctor who is having a patient of the femur bone fracture. So that doctor will give the CT scans or X-ray scans of the patient. So whenever you receive the CT scan and X-ray scan of the patient, you have to use a software called Mimic software. In the Mimic software, you can take the CT scans and X-ray scans, and you can generate a 3D part. You can generate a 3D part of the femur bone of a particular patient. And this femur bone is not same in all the human beings. It is having different. So here we'll be, so you have to take the CT scan and X-rays, then you have to make the Mimic software to make sure that you are generating a 3D model of this femur bone. And few of the femur bones are directly available in the online or in any few of the websites. If you see the human anatomy dimensions in the Google, then you can find the directly all the human parts dimension you can see there. From there you can download the dimensions and you can create the model in any CAD software, and you can import in the ANSYS. So for starting here, you have to click on, after installing the ANSYS software, we have to click on start. Then we have to click on all programs. You can find ANSYS 17.2 folder. In the ANSYS 17.2, we have to click Workbench 17.2. Then it will start. Workbench 17.2 will start. It will take some time to load, depend upon your RAM speed. It takes some time to load. Then after starting, there are different type of analysis setting in the ANSYS Workbench. So this is a structural analysis. So we are performing only structural analysis, and we'll check what are the different loads it can take on the femur bone. Okay, so this is your design assignment. There are different analysis settings. So design assessment. So if you have any idea, you have given any dimension, it will assess whether your design is correct or not. Next, eigenvalue buckling. So you already learned eigenvalue and eigenvectors. So for buckling loads, we'll check the eigenvalues. And if you are performing any electrical for any voltmeter and potentiometer, then you want to finding the voltage, then you have to use this electrical analysis. Next, explicit dynamics. So in this explicit dynamics, we'll be performing any crash analysis or any drop down test. In the crash analysis, we perform such as a car is hitting a wall, we can perform in explicit dynamics, or else any mobile phone dropping from certain height to the ground, that can be performed in explicit dynamics. Next, if you want to perform any blow molding analysis, then we will be using fluid flow blow molding. If you want to perform an extrusion, then we will be using fluid flow extrusion. If you want to perform any CFX analysis, computational fluid analysis, if you want to perform, then you have to use CFX and Fluent, both with respect to the air and with respect to the water. We can perform the fluid flow analysis. Next, polyflow, more than one flow we can perform in the fluid flow. Next, harmonic response. So in the harmonic response, what we do is we will apply the forced vibration. We'll see the frequency response. We'll see the what is the amplitude, what is the frequency, what is the phase angle, or which related to the vibrations. All we can see in the harmonic response. And coming to hydrodynamic diffraction. So we all know that we have little diffraction. So those with respect to hydrodynamic, we see the diffraction. We can analyze all the diffraction by using this analysis system. Next, hydrodynamic response. So when we are applying hydrodynamic forces or anything, what is the response of the object? We can see here. Next, IC engine fluent. So in the IC engine, what happens is the gases will flow. So all those gases flow for the inlet valve, outlet valve, all we can perform in IC engine fluent. And IC engine 40. So any with respect to gases, any damage is occurring or any fatigue load is acting, all those things we can perform in the in this module. Next, magnetostatic. It will see the what is the magnetic force or magnetic pulse around the around your object. We can perform those things. And model. And in model analysis, we perform the any natural vibrations. What are the natural vibrations with respect to any of the self weight? So due to self weight, the natural vibration occurs. It will generate different types of mode shapes. All the mode shapes we perform in the modal analysis. So if you want to perform the random if you want to if you want to perform the harmonic response is a forced vibration. Modal analysis is a free vibration. So after performing free modal analysis only, we can directly send the data to harmonic response and we can find the frequency, amplitude, etc. in this case. Next, random vibration. So here we don't know where the vibration starts, why the vibration starts, all those things. Then we can perform the random vibration analysis. Next, response spectrum. So if you want to perform any optimization, what is the response to your load on the material, that we can perform on the response spectrum. Next is the rigid dynamics. In the rigid dynamics, such as your any crank lever mechanisms or any slaughter lever mechanism, all those mechanisms we can perform the rigid dynamics analysis on the by using this rigid dynamics. Next, static structural. So as the name suggests, it is a static and it is a structural. We perform only structural analysis in this one. Next is the steady state thermal. So whenever we apply the thermal analysis, it is making a steady state with respect to the atmospheric temperature. It is making a steady state thermal. Then we can perform here. Next, thermal electric. So in few of the components, we both loads such as thermal is involved and electrical is involved. In those cases, we perform the thermal electric analysis. Next, coming to the transient structural. So transient is with respect to the time. We will perform the structural analysis. So static is completely static, and transient with respect to very small amount of time, we perform the static structural. Similarly, we have transient thermal. So thermal analysis with respect to the certain time. And turbo machinery fluid flow. So if you see any turbo machinery, it has turbine blades, all those things. If you want to analyze those things, how the turbine blades rotates, how the flow of the any steam or any water there, then that analysis we can perform in turbo machinery fluid flow. So here our analysis of a femur bone is on static structure. So we are selecting the static structure. So this one you have to drag and place it in the project schematic. So either you can drag it and create a standalone system, or else just double click, so that automatically you will generate it will generate the project schematic. So here you see the letter A at the top. So if I'm moving and placing the any transient thermal, then I'll get automatic the letter B. Okay, so we can perform n number of analysis. If your RAM is very fast and if your processor is very small, we can we can analysis all those things. And if you see this static structural, first one is static structural. The module what we select is static structural. Second is engineering data. So here we have to give the any material properties. If you have any new material, recently we are using version of ANSYS 17.2, but in ANSYS in the year 2022 you have invented a new material that you want to perform analysis, and here in the engine data you are not available. Then you can add your own material. You have to know the values, such as if it is isotropic, you have to know what is the density, what is the Young's modulus, what is the Poisson ratio. If it is an anisotropic, you have to know what is the Young's modulus in XY, YZ, ZX, and Poisson ratio in XY, YZ, ZX, and what is the shear modulus, what is the rigidity modulus, all those things you have to know. And if you have created a new composite material which is called orthotropic orthotopic material. So it has you should have find the what is shear stress in xy direction, yz, zx, shear modulus in xy, yz, zx. So you have to find and you can create your own model. And if you see the other things 3, 4, 5, 6, 7, all are question mark. So we haven't defined anything. If it is defined, automatically you will get as a tick mark. So in the engine data, so default it is tick mark. Even though we haven't gave any engine data, it is default tick mark because structural steel is already available. We have already kept the structural steel on the engine data. So if you want to change the structural steel to anything, just double click the engine data and add your any material. So it will see default is structural steel. And if you want to add, go to the data source, click on data source. Here you have any general materials. You'll get list of general materials, and here I'll select stainless steel. So suppose for the bone, if I want to insert any stainless steel or titanium alloy or any vanadium or those things, aluminum alloy, anything, I can add material. So you can see that a book symbol, which is the A2 symbol, it is added in the C column. Whenever it is added in the C column, it means that it has been added to your material properties, so that directly whenever you are selecting the pick, whenever you are selecting the model, directly you can assign the material, different types of material you can directly assign. So after assigning the A2, close the A2. So default it was tick, so it will tick only. Then geometry. So generally it is very difficult to draw any geometrical complex geometry in the ANSYS. So what we do is, what we have learned in the CAD software, we use a CAD software for modeling all those things, because we can edit easily in the because it is a parametric, we can Creo parametric, and Creo is a parametric language, so we can edit easily. And if you have exact dimension in the AutoCAD, you can draw it and you can extrude, press, pull, etc. So but coming to ANSYS, it is a very difficult to model in the ANSYS. So that's the reason we model in CAD software and we import here in this one. So geometry, right click the geometry. You'll get two types of modeling softwares. In ANSYS provides two types of modeling software. One is new space claim geometry. It is just like a CATIA software. If you have learned CATIA software, if you are easily understand CATIA software, then you have to use the new space claim geometry. If you are mostly using any Creo, AutoCAD, any other smaller software, then you have to use new design modeler geometry. So I click new design modeler geometry. And after opening the new design modeler geometry, then I have to import the what are the CAD file I have already downloaded, or I have modeled in another CAD software. I have to. So this is your static structural analysis. So here you can see that there is no model here. Parts are 0 parts and 0 body. So here you have to click on file and you have to click on import external geometry file. So we have to click on import external geometry file. It will ask the location. So I'll go to the downloads. In the downloads, I open ANSYS file. Then I'll select Femur CAD IGS. So it will better if you use any IGS file format, so that it can be easily transferred between the different CAD softwares. So it takes some time to import. And here you will see the yellow color Thunderbolt, and it means that it is not generated. So if you want to generate, again you have to click this one. If after generation you will see a green color tick mark. And after importing, if you want to make any changes, you can change in the design modeler. You can change, you can make all the changes available. And if you want to import anything, if you want to give any parameters, all those things you can do. So this is your femur bone. So this is the bone where it is attached. So this is the top portion which is attached to the hip joint, and this is the bone which is attached at the bottom. Okay. So same model we have created. Generally, we create the model by using Mimic software, by taking the Mimic software by taking the CRT scans and MRI scans. We merge them and we'll get this one. Okay. And this is a surface. and on the surface only we can apply the loads, not on inner face. Okay, then click on file and close the design modeler. So you are closing the design modeler, then you have to start the actual model setup. This model is half only. What are the geometry you have done, this has sent to the model, but you have to define few of the terms, such as what is the material, what is the connection, what is the meshing, all those things you have to set up in the model. So it is only half. Until unless you click and you refresh, it don't update in the model. So you have to double click the model, then it will start. Then you can see the model, and for that model you have to assign the material. What are the material you are taking, you have to assign the material for that one. So it will take some time to load. And here we are performing the structural analysis on the femur bone, and what are the loads it can take, we are applying those loads here. So it will take some time. You can see the overall progress. When the overall progress is completed, then you can see the it has been started. Okay, so this is the geometry what we have done. Okay, and this is a geometry. So this isometric view. So whatever view we want, we can rotate. Click the middle mouse button or scroll button, and you can rotate this bone on your own. Wherever you want to rotate, you can rotate your bone. Click the middle scroll button and rotate the mouse, and for scroll in, scroll out for zooming in and zooming out of here. Okay, if you see the geometry, it is already like a surface. It is geometry. Select the geometry. So default geometry we have as a structural steel. So I want to change the structural steel. So I want to keep it as stainless steel, because we insert few of the stainless steel rods so that it doesn't have any rust formation on the bone. Because after fracture we can't remove the bone, so we place any plates or any rods, stainless steel rods we place inside the bone, so that we can apply so that it is resisted to the what are the loads we are applying when we are running, walking, or sitting up, pushing push-ups, all those things we can use this one. Okay, so I have assigned the complete geometry. I have assigned the stainless steel, because we manufacture this one by using the additive manufacturing. So additive manufacturing, it has stainless steel, titanium alloy, and vanadium, all those things. In the additive manufacturing, we can generate the model by using the biomaterial. We have biomaterials in the additive manufacturing machines, so that we can directly generate. We have to take the first we have to take the scans of the patients, then we have to convert by using mimic software, and then after we have to perform analysis. If our analysis is satisfied, then directly we generate by using additive manufacturing, we generate the biomaterial. Okay, so meshing, it has a thunder symbol, so I have to right click and I have to click on generate mesh. It takes some time to generate the mesh. Depending upon your RAM speed, it will take some time to generate the mesh. So there are total 100 segments. It has started. It will verify all the 100 segments, then it will perform the meshing. And importance of meshing is that one. So if you are not meshing, the complete component has infinite number of values, because the complete component has infinite number of values. So in the meshing, we perform that infinite number of values we are making it as finite number of nodes or elements we are making. Then only it will perform. Until unless you perform meshing, you cannot go to the next step, applying the load or solving anything. You can't go until unless you perform the meshing. And if you want to take any image of this one after importing, because whenever you are writing any research report, or whenever we are publishing any papers, we have to take the images. So for taking the images, you have to make sure that you are taking the high quality images. So in the ANSYS, you will get very high quality images. I'll show how to take the images in the ANSYS Workbench, and how to take any result analysis, result video you will get. We will divide into result video in number of frames and number of seconds, how many seconds we have to generate. That one we'll be making as a GIF, in the GIF format, so that whenever we are presenting on a PPT, so that it will have a continuous continuous movement from starting to end. Again, it will create a loop such a way that it will go from ending point to starting point and starting point to end point. Okay, still it is taking some time to load. So already I've shared this CAD model in the WhatsApp group. So whenever you want to perform any analysis, you can perform the analysis of the femur bone. This is the so right now in the mechanical, if you collaborate with the biomechanical analysis, so we can publish many papers compared to the only mechanical scope. So most of the universities, if you want to study in MS or do PhD in higher university, so it is they are using all this high sophisticated thing. And not only this one, we can perform on any of the human bone or anything. Like you can perform the analysis on a skull if you have any fractured skull, if you have any fractured mouth jaw, if you have any fractured hip joint, if you have any elbow joint, all the analysis you can perform. Just we have to know what is the dimensions of the bone of the patients, and we can import it and we can start those things here. Okay. And after performing the meshing, we have to go to static structure, which is A5. So the meshing has been performed, and if you click the mesh here, you can go for sizing. You can go for sizing, and here relevance center. This is a coarse mesh. Whenever I say coarse mesh, it is not a fine mesh. It is having larger diameter, so I have to make it as fine mesh. So absolute mesh, again have to generate the mesh, and also if you see the mesh, it is span angle. It is I'll make it as fine, but it takes more time to mesh. Okay, and if you see the size function, okay, not the size function. If you see the element size, if I can define number of element size, if I want to limit this element size to 500, I can limit my element size to 500. Okay, and coming to transition, it is fast. All those things we can make this all the settings in this one. So if you go for smoothing, you want a smooth finish, you want medium finish, you want high finish, you can have those things. Okay, if you want a faster rate, if you want a slower rate, all those things you can apply here. Okay, then in the meshing I will insert, I'll make it as refinement. If I want any refinement, if I want any sizing, I can include refinement. To add the geometry, I'll select the complete body, or else whatever I want to select, you have to click on control button and then select all these things. Whether you want any sizing, if you want to apply anywhere, you because this is a main portion where you take the loads. So if you want any sizing, we can apply the geometrical refinement, we can apply. Okay, so we are applying the refinement here. So default we can select any element size, all those things we can select all these things. So I want the sizing applied completely on here. Okay, and then I'll click on generate mesh, and again it will take some time to generate the mesh, because meshing is important value. Because if you want to get a very high correct values, because this is a this component whatever we manufacture by additive manufacturing, it will directly be fixed in the patient's body, and if you do any mistake, then it will have any problem for the meshing. Okay, then meshing has been completed. So if you see the mesh, here, so this has been very smaller fine, but here a very larger coarse mesh we took, because here the main thing, it will take the loads. Okay, so next, static structural. So in the static structural, if you see the loads, what are the loads this can take? So if you see the loads, what are the loads it will take? So here it is it is fixed to the it is fixed. So here we have to apply the force. Here we have to apply the force of example 3000 newtons. We have to apply the force, and then we have to apply the movement, because when we are running or anything, we'll the movement, small movement will be applied. 500 Newton movement will be applied on that part, and we need to have one fixed support. So that fixed support will given at the bottom. So if you see this sketch here, so here we apply the force. This is the area where we take the force or movement, and this is the where we give the either cylindrical support or a fixed support at this point. Okay. So here I'm applying the, I have to insert, I have to go for the, I can apply as a pressure or a force I can apply. So I'll apply the force, then I have to click on, it will ask by vectors. So you have to first select the geometry. So I'll click the control button and I'll select the geometry. What are the shape it is in contact? What are the shape it is contact? I'll select all the shape which is available here. I'll select all the shapes which is available here. So this is the portion where it takes the loads. Okay. So select all the curvatures here, all the surface here. What it is with respect to the components. So if you go to isometric view, it is acting in the, it is acting in the negative, in the, it is acting in the positive x direction. So I have to go for the, in the vector I have to go for the components only in x axis, only in x axis it is component, or else so I'll select the vector, I'll click on components in the x axis downwards it is acting. So I'll give it as positive 3000 Newton, 3000 Newton. I'll click enter. So here I'm applying a 3000 Newton on this component. Then I'll apply the movement. I will insert a movement. So for movement also I have to select the same. Click on control control keys on your keyboard. Then select the, move your cursor such a way that all the portion is selected on this part. You have to select all this. Click on control and select all this portion, and in the magnitude, again we have to go for components. So here also it is acting in the x axis, here also it is acting in the x axis. So here also it is acting in x axis. So I'll select all the component here. So I'll select the geometry first. I will select the geometry here. So it has been selected. I will unselect these things. I will select all these things, geometry called apply, and x component. In the x component, the movement comes as 500. So here we are applying the movement. So these are the loads. What are we have applied the loads. Then we have to see the results. Yeah. Okay. Then after here, we have applied the force and movement. Then whenever we want to perform the analysis, we have to give a fixed support. Until unless you give a fixed support or cylindrical support, it cannot hold and it will deform continuously. So right click, insert, then you have to give a fixed support at the bottom. Okay, so I'll select this one. I'll click the control button. So what are the bottom face is there? All the bottom face, I have to give a fixed support. So what are the bottom face are there? Select carefully. All the bottom faces, you have to make it as a fixed support. Whatever maybe the bottom faces, you have to make it as a fixed support. Okay, so this is enough. Okay, so actually it will differ from patient to patient, so we can't predict where it will act exactly. So randomly at this portion we assume that it will act as a fixed support. Okay, and then click on apply. Geometry equal to apply. 54 faces are selected. You can select up to 30 to 100 faces. Any faces you can select in this case. And then it is also a thunderbolt, so you can right click and solve. So if you click here, you can see all the three loads. What are the loads you are applying? All the three loads you can see here. So this you have to save the image. So if you want to save the image for your publishing papers or any writing thesis, all those things, you can click on print preview. So whenever you click a print preview and scroll down, you can see what are the component with respect to the date, time, etc. And here it is overlapping. If it is overlapping, I can't see the value. Then again I have to come to geometry. I'll zoom out, and again I'll go for print preview, and again it is small overlapping. Again I click on zoom out, then I click on print preview. Then I can see that it has been generated. I can make it as any orientation. Whatever the orientation I want, I can make it as my own orientation. So wherever I can see the loads, all those things I can make it as my orientation, my own orientation I can make, and I can see. And again it is overlapping here, so again I'll click on zoom out. So print a preview, and again now it is soon. So whenever I see this letter C, it means that here I have made a fixed support. And whenever I see the A is another force I have applied of 3000 newtons. And whenever I see letter B, red color letter B, it is 500 Newton mm. I am applying the movement at that point. Okay. So if I want to save this image, just right click, save picture as, then go to your location, any location. Here I have saved as ANSYS files. In the ANSYS file, I will make it as a PNG. It will default saved as PNG. So you have to make sure that keep the word .png, just write loads, and you can save in your folder. Okay, and you can see the folder in whenever you want to see, just double click and you can see. And this image you can keep it in any of your paper publishing. You can send those images. Then again go to geometry. So loads have been completed. Now you have to see the results. So what are the results we see? First we see that after creating this model and after applying the loads, whether the model able to sustain or not, what is the stresses induced in the model after applying the load, what are the total deformation of the load, what are the fatigue it can take, what is the factor of safety it can take, what is the life of this one. If you apply a fatigue load, what is the life? If I apply a stress, what is the life? All those things you can see in the solution. So here I can click on right click, insert, then stress tool. So it is a stress tool where continuously stress is applied. So in the stress tool, I will select the maximum equivalent stress. In the solution, again I have to right click, go for deformation. So there are two types of deformation. One is total deformation, another is the directional deformation. Whenever I say total deformation, the total deformation is in the XYZ, because you have three coordinates XYZ. I can see the total deformation XYZ here. If I see only directional deformation, then I can see only in which direction the force is applied. Where I can see only that. I'll click on total deformation so that I'll know everything. And if you see here, I have given a fixed support. Yeah, you can see here that I have given a fixed support. Whenever I gave a fixed support, there's a reaction for the support. And if you want to see what is the reaction value at that point, then what you have to do, just click the fixed support, drag it and place it in the solution. So in the solution, automatically you can see the force reaction. So automatically you can see the reaction of the force due to the fixed support or any support, cylindrical support or fixed support. You can see the reaction force there. Then again right click, insert. So deformation completed. Next, strain. In the strain, mainly we see about equivalent von Mises strain. Then again right click, insert. In the stress. In the stress again we see the equivalent von Mises stress. Again right click, insert. Again go to stress. In the stress we see the maximum principal strain, principal stress induced in that component. Again right click, insert. Then again if no strain energy is not required, linear stress is not required, fatigue. So in the then you have to go for fatigue tool. If I click the fatigue tool, you can see the amplitude load. What is amplitude load? You can see the SN curve, you can see Goodman's curve, Soderberg curve, Gerber curve. You can see the yield point, you can see the ultimate point, all the things you can see in the fatigue tool, and it is a question mark. So you have to click on fatigue tool, right click the fatigue tool. Again in the fatigue tool, you can see the fatigue life. You can see the fatigue life of the component or bone. You can see the fatigue damage. What are the damage? Where the damage will occur if you apply a fatigue load? Then again insert. We see the factor of safety. What are the factor of safety? We can see the applied fatigue tool. Then again we can insert. Then we can see the alternating stress. If you are bearing the stress alternatively, we give positive stress, we give negative stress, continuous, we give tensile, compressive. Then we can see the equivalent stress. All those things we can see in the fatigue tool. And here we kept the stress tool. In the stress tool also, default we have seen the factor of safety. Because of stress, what is the factor of safety we have to give? And because of the fatigue, what is the factor of safety we can give? All those things we can see here in the solution. Then right click the solution and click on solve, or else you can click on F5 on your keyboard so that it will start generating the solutions. It will take some time. Whenever the overall progress is completed, then you can see the all the results. What are the results? So you can generate the graphs. You can see the graphs. You can export. You can see what is the total deformation, how the deformation starts, how the deformation ends, where is the maximum point, where is the minimum point. All those things you can see in this one, and you can make your own analysis. You can make your own conclusions in your paper, research paper, when you are publishing a research paper or any projects, MTech projects, BTech projects, or PhD projects. You can see all those things. Okay, so I will again evaluate all the results. Record fatigue module invalid stress. So in the fatigue tool, in the fatigue module, it has been made as an invalid. So I'll delete this data. I'll see the other results later. I will apply the fatigue stress. Okay, so it is saying that the material cannot take the fatigue load. Due to the fatigue load, this material fails. So we'll see any other material fatigue. We'll see. So in the fatigue tool, I will run one by one. I will insert the life. What is the life? I think life, we can evaluate the life in the fatigue tool. So it is not taking that fatigue tool also. It is not taking minimum and maximum. So in the fatigue tool, display time is 0.2. Analysis type, stress, life, mean stress theory. So what are the theory you want to apply? Whether Goodman theory, Soderberg theory, Gerber theory, all those theory you can apply. So cycle. So here one unit name is cycles. Yeah, we are measuring in the cycles, and one cycle is equal to 1. There is no change in this one. And here you can give the fatigue strength factor. We can apply this fatigue strength factor. Okay. Fatigue module invalid life stress life curve. It is unable to select the stress life. So it is not working. So right now I'm deleting this fatigue tool, but you can analyze the fatigue tool. Okay, so you'll get all the information. So this is your solution. If you want to see the total deformation, then you have to click on this total deformation, and you can see where the total deformation. If you want to see what is the minimum and maximum, so if you want to see smooth curves, if you want to see no wireframe edges, so this is your actual bone where it is the load is applied here, and here's the fixed support. Because of the fixed support, you can the results are very small here in this case. And if you want to see any of these things, So you have to click on play the animation so that you can see the animation, and here you can edit your animation. So number of frames it will ask. There are 10 frames. I'll make the frames as 40, and I'll make the seconds within 2 seconds. I want approximately 4 seconds, and I'll play the image so that how the deformation starts whenever the load is maximum. We have applied a 3000 Newton force. Whenever we are applying 3000 Newton force, so it will start with the 0, 50, 100, or 0, 500, 1000, 1500, 2000. So whenever we are increasing the load in the steps, so I have created total 40 frames. So with respect to the that load is increased in the, we have made it in a within 4 seconds. We want seeing the results, and click on here. And if you want to save this video, then click here. There's an option called export file. This is option where you see this one. This is called option file. Then you can write, it will save it in the .avi file format. Then you can say that this is the total deformation. This is the total deformation what we can apply here. So total deformation, and we can save the video. Again, go to your folder. So this is your animation video. Then you can click on your animation video. This animation video you can convert into GIF format, and you can insert in your any of your PPTs. When it will create a continuous loop, so that it will be helpful. So whenever you are presenting your PhD thesis or any MTech project, BTech projects, it will be helpful for you to show in the PPT, so that the evaluator will understand what you are doing. And if you want to save the image, same thing. Again, click on static structural, and if you okay, so you can save the image. Right click, save image to clipboard. So directly you can save this image also to the clipboard, and again you can open any paint software or any other thing. There you can paste, or else you can open any Word format. Right click, copy image to clipboard. You are clicking it as Control C, it will copy. Then open any Word format and Control V, so that automatically it will save in that file format. So this is the minimum, and maximum total deformation is 1.5956. Next, factor of safety. So maximum, if you give factor of safety as 15 to this portion, then it will be safe. So you are seeing that it has a red color highly damaged. It will damage here. So if you give a factor of safety of 15 to this one, and factor of safety of around 10 to this portion, and factor of safety around 2.92, then your deformation are very minimum. In the case, you can know the factor of safety, which where you have to give the material, what is the yield point, how much factor of safety you have to consider. Next, force reaction. So with respect to this one, with respect to 3000 Newton force, we get a reaction force of 2.1189 e power minus 5. So force reaction X y-axis, force reaction z-axis, force reaction, total force, what are the force you apply, everything we can know here. And coming to the equivalent strain. So if you see here, if you want to know where is the maximum, where is the minimum, click on maximum. You can see that this is a maximum point, and this is my minimum point on this portion, and maximum point on this portion. Again, you can click on graph. You can see the video, how it is slowly moving where. So we can say that we have a very high chances of fracture at this portion, not at this portion. Even though the load is applying mostly on this portion, the maximum fracture will occur at this portion. And here, if a fracture occurs in this portion, here we have to place any stainless steel rods or any other rods, so that it has to withstand the load. And coming to the equivalent stress, same thing. If you see the equivalent stress also, this is a portion where we have the maximum stress, and minimum is at the fixed support. So because it is fixed support, it will definitely it doesn't feel any stress, because it has a support at the backside. And here it doesn't have any support, and in here there's a high chances of failure, having a fracture. Bone will break at this portion. And coming to the maximum principal stress, so here there is no maximum principal stress, so the value are very minimum at this point. Okay, and so these are the things we can generate here. Okay, so if you want to see the solution information, So here ANSYS 17.2 give the legal notice. Whatever they have done, it is legal, and whatever they have taken, how they have calculated the body mass matrix, how they have created couple translations, rotational mass inertia, principal inertias, all whatever they have done in the background, all the formulas will be explained here. So it will tell what is the solving time in seconds, what is the post time, what is the complete time in order to solve all those things, number of cores available in your PC in order to solve all those things, where it has saved. Suppose if you don't know, now I haven't saved anywhere, but unfortunately suddenly power loss or anything lost and I have lost my file, then I can find it in the this PC name users, this folder app data local temp. In the temp file it is saved. So whatever I have done, everything is saved in the temp file of this path. If I go to this path, I can directly find my file and I can recover my file, and how much time is taken to complete all those things I can generate here. Okay, and also, okay, so these are the things. And if you want to see any report preview, I can go for report preview. It will generate a report for me. So in the report only I can get all the images. So this is my model image. Instead of saving the individually, if I click on report all the images, mostly I can save these images. So it will tell what is the product version, all those things, and that you can't convert into PDF. So directly you have to save everything and you have to copy it in your bird format. You have to save. So it will see what is the angle units you have taken, what is the rotational velocity units, what is the temperature units you have taken. It will generate what are the number of nodes after meshing. It has 49,703 nodes, elements 30,322 nodes. So in few cases, these are also important when you are manufacturing, when you are performing analysis. The evaluator will ask why you have taken consider the less than 50,000 nodes, why you haven't considered 1 lakh nodes, so that your accuracy will be improved. All those things they will ask. So you will see what is the mass of that bone. The bone mass is 4.2325 kgs. What is the volume? All those things. What is the length in x-axis, length in y-axis, z-axis? What are the thickness, length, width, and height? So which type of mesh you have taken? What is the properties? What is the moment of inertia? What is the centroid for that centroid of x, y, z for that model? And what is the axis directional vectors? Whatever you are taken, everything they will be mentioned here in this case. And what is the element type you have taken, default, total, how many faces you have selected for meshing, and all those things. What is the temperature? Environment temperature is around 22 degrees Celsius. What are all those things we can see here. And what are the type of load we have applied? We have applied the total 3 loads. One is the force we have applied, second is the movement we have applied, next is the fixed support. So all those things you have seen. For force I have took 30 phases, for the movement I have took 29 phases, for the fixed support I have taken 54 phases, and for the force I have applied a value of 3000 Newton, movement I have taken a 500 Newton, fixed support, it is a fixed support, so everything will be 0. And you can see the component, x component, y component, z component, and how the force is distributed. The force is distributed from 0 to 3000 at a single stretch. It has been done within 1 second. The force has been applied, and movement within 1 second the movement has been applied, and how much time it has taken to solve the result. All those things, everything you can see in the results. So if you want to see the total deformation, you have to copy this result to the work Excel sheet or the work or the Word. Then you can copy the image, and from the image you can directly generate what is the actual total deformation you have generated. Okay, and what is the stress tool, safety factor, all those things. For each and everything, different graphs will be generated. It is saved as a PNG. You have to copy into the either Word format or Excel format. There you can adjust the size. If you adjust the size so that you can see the values, you have to, there you can edit the value. What is the maximum value you can keep for this component? What is the minimum value you can keep? Then you can automatically get the graphs generated, or graphs will be generated automatically. So all these graphs, maximum principal stress graphs, we are taken in MPA with respect to second, all those things we can generate. And here also, and if you want to see, so this is my geometry. So I will set any of the tool. So this is my one. I'll click on fit to view. So zoom to fit. So this is my zoom. And then if I want to one more thing, if I want to measure with respect to any distance, I want to measure any force, so I can use the probe. I can go for mesh. Once I'll go for mesh. So if I go for the mesh, and if I want to see the result here, if I want to see any of the result, I will use the probe. So the probe, whenever I click a probe at this point, it will show that the value is 1.4984. So what we do is, generally, if you want to generate with respect to any certain distance, what we do is here we create the probe, and here we generate the different number of probes we generate at this shape. What are the different values we get? You can copy this value and directly you can create, go to Excel and you can create the graphs. What are the graphs you required? You can create required graphs with respect to length. Suppose this, we have seen the total length in x-axis. What is the total length in x-axis? Already we have seen. With respect to that length, we can make sure that we can divide into a number of probes, equal number of divisions. We can make equal divisions, and then from that point we can generate the graph. We can draw the manually, and we can generate the graph. What is the length x, y, and z? Okay. So if you will click on the probe and we'll select wherever we want to see the value, it will generate. And these points we can directly copy these points and in the Excel, and we can generate it. Okay. So this is a deformation what we see in this one. So already I have told how to save the images, all those things. So this graph also you can retrieve this result and select all. You can retrieve the results. You can copy in the Excel and you can make all those things. What are the things are possible, you can make it as possible. Okay. So this is the area where it will fail. Okay. So here is the area because of this force. Because of it, it is having such like a bending moment. So here it has a force. Here it is resisting. So at the middle, you have a maximum fracture here. So here we will be keeping any prosthetic plates. We have to keep any prosthetic plates in order to have very stronger stiffness of the femur bone. Okay. If you go to Google, if you type, there are so many femur bone fractures available. So you can take any case study and you can perform the analysis and publish a paper on this topic. Okay. And here I have took only one material. So for the next material also we can perform. If I click on geometry, I took stainless steel. So here I can take aluminum alloy and I can perform all the things once again, and I can see the results, and I can compare all the results with respect to the both the things. I can perform all the results. Okay. So all these are possible. So all these are possible in the ANSYS Workbench. So you can compare automatically. You can compare between those things. Yeah. Any doubts from any of the participants? Either online participants or offline participants. Any doubts, you can unmute and you can ask. Any doubts from any online participants or offline participants? So if no doubts, I'll be ending the session. If you don't have any doubts, I'll be ending the session. I hope no doubts.